Hello. So this video will be to showcase the CheckPoint shift left toolkit that provide static code analysis as well as Terraform code configuration posture management scanning. It is called shift left. It is a toolkit that has multiple blades, and there is one blade for the code scanning. There's one blade for the Docker container scanning, and there's one blade for the Terraform configuration scanning, and it basically looks for the main tier file that has the Terraform configuration in HCL code. So here there is a repository that's available for everyone to have a look. It is located on the CheckPoint community GitHub site. You could go to CheckPoint SW-community, and you can find it there, and you could basically fork it if you want, or you could clone it in your particular machine. Now, as you can see here, so essentially it is a Node.js application. It's very simple. It allows you that if you go to your local IP address, and you can change this to your IP address if you wanted to, if you have a virtual machine, to a certain port, you can change the port as well. That will give you a message if obviously the HTTP is successful. And you can keep that running. So that's basically the application. So it's very simple. So the goal is to inject malicious vectors like malware and to showcase the ability of shift left code scan to pick them up, and as well as doing container scanning, because then we'll build this code into a container. So we're gonna compile it into a container, and a container obviously is a simple container to use the Node.js official image from the Docker Hub from perspective. And obviously I'll be injecting the malware here. I'm going to be copying the malware files, as well as adding my source code so that I can have an entry point to run my application from the container when I do Docker run. And also have Terraform. So the Terraform is basically the main TF is to configure an EC2 with the provisioner, as well as a bucket where I provided, not this one, sorry, here. Hold on a second, where is it? I don't see it here. Okay, I don't have a bucket here, but I have a key pair and a security group accordingly. All right, and so here, just be careful. Please do not, if you run this demo, please do not run this in a production environment. It has to be in a controlled environment because these are backdoor and Trojan malware that are pretty serious. So I'll be careful. And the goal is to also showcase shift left, obviously from a shift left security perspective, by integrating and inserting natively our security, the shift left CLI toolkit into a Jenkins pipeline, but also as it is provided as a bin, or Go bin, which is essentially written in Go, as well as a container. You could integrate it into any CI/CD pipeline as a plugin, whether it's GitLab or AWS Code Commit or Azure DevOps, it doesn't really matter. And you can build your pipeline as you wish. You can have a pipeline to scan the code and then scan the container image and then deploy to a Kubernetes cluster. And then as well, you can use Terraform to deploy the cluster itself in a separate pipeline. It's up to you. Okay, so let's just do that. I have a Jenkins server right here. So we'll just create a pipeline to have access. Actually, I have a pipeline here, but I'll create a new one to point to the community. Let's just do shift left community software. Okay, and we'll create a pipeline. And okay, and all right, and so discard all builds. Do not allow concurrent builds. Obviously, just will save you hard drive space. Right, that should be good enough. Pipeline is from SCM, and I'll point it to the GitHub repository that is here. I just copy the HTTPS, and there is no credential needed because it is a public repo. And as I say, I forgot to mention, there is a Jenkins file here that allows me that basically describe the pipeline. The CloudGuard ID and the CloudGuard secret, the CheckPoint CloudGuard, these are tokens that you have to get for the API keys that will be available from the CloudGuard management tool. So you need to either contact your sales representative, or if you have a demo account, then just go to to the settings and credentials to generate one automatically, and I recommend encrypting, entering them into the Jenkins credential as a secret text. Okay, so for each, to at least you get it encrypted. So the first stage is to check out the code to the Jenkins pipeline workspace, and then we'll do the scan, and there is an approval stage that allows you to just to pause and then to decide whether you want to approve the code or not, and then build the container image. Now we'll see that you have to convert the container image into a tar file, and you use a Docker save command for that. For us to be able, for shiftleft to be able to do the container scan, that's a required step before doing the container scan. The same thing, and finally the Terraform configuration assessment. As you can see, the commands are image scan for the container scanning, IAC assessment for the Terraform, and then the code scanning is code scan -s for the source file. Well, it's not a source file, actually, it's a source directory, sorry. Okay, so let's just do the pipeline, and we'll do it step by step. So I'll save the pipeline here, and we'll go, and we can build it now. Okay, and I'll move to the console. So as you can see, the first step is checking out all the files to the Jenkins workspace. As you can see here, this code scan started. It's the dot stand by just scan all the whole folder, the directory that is a GitHub directory. It does create a project name because eventually you're going to have to go to a portal. You can have all the result in the GUI in a portal, in a graphical result. It generates a unique scan ID, as you can see here for the code scan. This will allow you to differentiate all your scans. So there's two phases to the scanning. Obviously, there's a scanning, and what we do in the scanning is we'll look for SHA signatures. What I mean by SHA is SHA, and each signature will represent a malicious potential threat. Meaning, could be credentials, could be malicious IPs, it could be malicious files, it could be vulnerabilities like CVEs, it could be and so forth. So that basically this is what we look for, and we catalog them by SHA signatures, and then we do not send customer data or any of your code back to our threat intelligence engine, which is called Threat Cloud. We only send the SHA signatures, and this is part of the analyzing. So we send our the scan result, all the SHA signatures found that are potentially malicious, to be analyzed by Threat Cloud, which is the world's largest threat intelligence engine, by the way. And as you can see here, it found issues. It found, in this case, a code potential problem, which is was listing on all addresses. That could be a problem, as well as potential credentials that I put fake credential for AWS. This is typical of developers or people using Terraform. Sometimes you don't want to spend the time in putting them into Vault or some other encryption, credential encryption system. So people just leave them in the file, either out of they didn't know or out of just I don't have time. But it will pick up AWS credential if it finds them. Okay, and it'll give you exactly the location where it found them. Okay. And then finally, you have this is a malware, so it's file reputation, malicious file. And he found the two malwares that I put. There is a backdoor Win32 and EvilBot, which is a pretty critical malware. And there is a Trojan generic Win32. So these are critical malwares, and that shows you the power of the threat intelligence engine that we're using with our scanners, our code scanners. Okay. And there is a portal you can go to correlate all this in the graphical representation. But essentially, there will be ported to CloudGuard when released. Okay, so this is how the code scan works from the shiftleft perspective. All right, as you can see, it's this is one of the blades that enable the code scanning as part of the shiftleft CLI toolkit. And the reason there's multiple blades is the effort from CheckPoint to provide a unified toolkit, a unified CLI to provide all the static code analysis functionality that you can have for your DevOps pipeline. Okay, so the next step is we'll move to, and typically you'll choose a board because it's a block, but I'll proceed because I want to showcase the container scanning. Okay, and the same thing. So the first thing we'll build in the container. Meaning this is from the Docker file, so it's actually creating a container. As you can see here, it created a container with the name that I gave it and the label, and then it converts it into a tar file. And then as soon as the tar file is ready, it will start the scan. Okay, so the .t is a timer. It's typically, in case let's say the scan times out, the default timeout is about 5 minutes, which sometimes we may not want to wait that long. So the D timer allows you to set a timer to in case of a timeout. And the I is image, and in this case the tar file, the path of the tar file. And the same thing, I'll give it a project name, separate one. So every scan have a unique project name. As you can see, there's a lot of findings. Well, let's just scroll back up. Okay, so same thing, scanning analysis. As I explained earlier, it did find the earlier, obviously the issues that was available in the code that I created. All right, so it did find it didn't find the credentials because that's part of the Terraform. It's not part of the container, but it did find the malware as well. Okay, so whether it's in the code itself or in the container image, in this case, it'll give you even the path with the malware within the container. So it will look at the whole file system and all the files within the file system as well, not just the container binaries. Okay, so that shows you the power of shiftleft as well, and it also found this is from the dependencies to run my Node.js application. Obviously, for that you have to have the Node.js container image, or you have to use the Linux container image like Alpine or Ubuntu, and then add all the libraries like npm and so forth. In this case, I just chose the Node.js because it has everything in it. And as you can see here, this is the official Node.js image from Docker Hub, and you can see that it found a lot of critical CVEs and also CWEs, high and medium, sometimes even unknown. As you can see, there's critical, but there's also some of them unknown, high, medium, unknown here. So it's even the threat intelligence is even capable from a threat cloud perspective to find unknown CVEs that are not yet classified. Okay, which is pretty powerful. And the list is this is the challenge that most customers are facing. They might not be aware of it, but as their developers are creating containers for their application, they are forced to use third-party open source containers because they have to. These are, every application that you run is created based on a certain runtime, like Node.js or C# or Go or whatever. And these requires you to get container images from third-party open source, like Docker Hub. And these will come with this type of CVEs, and it'll be the role of the developer to go and patch these or to find a way of hardening the container images. Okay. All right. So, and finally, the last step was to do the Terraform scanning So the way Terraform scanning works is you have to create rules, compliance rules that you do on our CloudGuard platform that in this case, what I was looking for, I had an S3 bucket, an EC2 instance. So I was looking at, obviously, an S3 bucket should preferably have server-side encryption because for security purposes. And it did looking at the HCL code in the main .tf file. It did notice that there was no SSC configured and flagged it as an error. As you can see here, it flagged as low severity, but I guess you can classify it with a higher severity if you wanted to, but this is how the Terraform configuration scanning will work. You can type specific what we call GSL rules, and GSL standing for the government's language that we use, which is actually human readable. This is the actual rule. As you can see here, S3 bucket should have encryption.service-side encryption rules. As you can see, so it's pretty human readable. That's one of the power that CloudGuard has to offer. That allows you to then scan, obviously, the whole Terraform directory where your main TF is located, and they'll provide you the assessment, either pass or fail, and then you can send using the API, you can send alerts and so forth. Okay, and or send that to whatever logging mechanism that you may have. Okay, so that's shift left in a nutshell. I hope this was clear, and thank you very much.